Hi everyone, this is a review and helpful video for you on the internal assessment for IB psychology. I'll be going over other things I did in class, but then you can, suggestion was to just like fast forward to what you need on the parts that you actually don't understand, and I'll point you in the right direction. So in terms of the IA, we have gone over this at the very beginning. What is it? It's required for you. It's part of your IB exam. This year it is, it's not normally 35%, but during COVID it was. It's usually 25, but it's part of your IB exam grade, so you really want to do a good job on the rough draft. This is where you're going to apply all the skills from Unit 1, and we're going to be replicating that study, which we have already started to do. The written report's really important, and the way that you collect your data and discuss your findings will be the most important thing. So your thinking as well as the structure of it. What we've already done is we've already chosen a topic and we've thought about the theory or model. The theory or model of that review journal that you guys had looked at before is really important. Again, you've all been doing an experiment where you have an independent and dependent variable, so that is fine. And you definitely have different conditions that you have. No more than two. Some of you should only have one, but if you can compare data, that's good too. And then there's only one dependent variable. You're only measuring one thing. Again, the word count is going to be 1,800 to 2,200 words. You want to go to about maybe 2,000 words to be safe. That way that you know that your intro and your evaluation, where you're really discussing what's going on with the theory and the results, is really robust. The different components that you have in the different sections of the IA is the intro, exploration, analysis, evaluation, works cited, and your appendices. And you can find those in the check sheet as well as the yellow book. We also have to remember some ethics, and that will be something that you're going to put in your exploration. Things to think about as partial deception is one of those things, that we are partially deceiving, so they don't know the real aim, but we're not causing any harm. That might be, deception might be one of those guidelines that you talk about. But refer to Unit 1 vocabulary for anything like ethical considerations in this section. Other things might be, voluntary, the use of a consent form, and so forth. So just so that you are following along, there is a sample IA that we went over in class in the yellow booklet. It's about 4 pages in from that yellow booklet. It's the anchoring effect by Strack and Museweiler. It's based on that, and you can use that along with your check sheet as we go through the video. So in planning your discussion, your investigation, you did all kinds of things as a group. That peer review journal is in your group folder, as well as all of the questions that you all put together in your group folder. The group folder will also have the different things for your appendices. The copy of your, for instance, the copy of your consent form, your standardized instructions, your debriefing, your data recording sheet, as well as your raw data graph that you should have. The questions that you guys answered about the theory and model and experimental design will be helpful when you're writing your own exploration in that section of the IA. Then we did an experimental prep days and so forth, and you've done your experiment. So now we're ready to write our actual IA. The first section is called the introduction. You have on your check sheet that you see in front of you, you have a section at the top that talks about the title page, and then the next page is the table of contents. The introduction is where your word count starts. And when we look at the rubric for this, you have to, in order to get the full mark bands, the aim of the investigation is stated, the theory or model is discussed, and the independent dependent variables, as well as the operationalized null and research hypothesis are included. So those are definites that need to go in. If you follow the check sheet, you will absolutely get the highest marks, especially with having what you need in there, and it's going to be you just explaining it in the right way to get the full marks. So if we take the check sheet, and I've expanded it out from the check sheet, and you take your yellow book and look as we follow along on the intro, you'll see that the introduction is a little bit long, but it's not too bad when you split it up and look at the check sheet. So first of all, you're going to talk about the background and general explanation of the topic. So these things are, maybe memory, and what memory is, and how they've been studying memory for a long time, and cognition for a long time, and so forth. If that's what the memory. The one on the right-hand side of the slide here, you'll see it says it's a global trend that eating disorders are on the rise, and then it's cited there because that's where their research came from. Could the increased access to media be a reason for this? Numerous studies have investigated the link between media exposure and risk factors of developing eating disorders, and they also cited that. One of these risk factors is body dissatisfaction, which means to be unhappy about one's body. Now, of course, this is an intro of an experiment we would never do, but because it's in there, we're just looking at the structure, not the type of experiment that would have been done with this. We couldn't do this in our own school, and it gives an example so you can see the format of it, and you're not going to copy just the actual wording of it as well. In the example there, you see the next part of the introduction, which is B, discussing the theory or model. This is really, really important. You're also going to cite this as well, because any information you find out, definitions and models, you're going to cite. With the theory or model, you do not want to cite the textbook. Find some other source that's not the textbook. So you're going to name the name of the theory, and the researcher is going to be cited in there, and then the claim of the theory. And then after that, you're going to show how the use of the theory is explained in the independent and dependent variable. So C is going to be the explanation of the original study. So what study you're actually replicating, and discuss the details relevant to your study. And you can see that in the introduction in the yellow book. It's kind of a big chunky third paragraph, I believe, and it shows what the study was, and it talks about the aim, sample, design, essential like procedures, controls, and even put some of their numerical results, some of their statistical results of the original study. You're only putting details in, though, are about your replication. If your study had 5 different experiments, you don't talk about all 5, you only talk about the one that's relevant to you that you modified and replicated. So you only want to talk about essential procedures of the original also that are applied to you only. And then what you're going to do finally, as you can see in the yellow book, is put details on how you simplified or modified the study. And a lot of you did do this. You did one part of experiment 1, and you're going to talk about it's a partial replication and what that looks like. In terms of writing the introduction, you're going to explain its relevance, right? So one of the things you're going to do next is you're going to put down the following research is a blank. So as you can see in the yellow book, it has that exact wording. The following research is a blank replication of the original study. So that's how you're going to talk about like how you partially replicated it. Then what you're going to do in your intro is write the aim. The aim of your study is to investigate, and then you're going to include the independent, dependent variable and a cause and effect relationship between this, and it's going to be more on a construct level and not an operationalized level. And I'm going to go over that in just a second. Then you're going to show how the aim of your study is linked to the theory, your aim of your study. Even though you've talked about how the theory is linked to the original study, you want to talk about it also about your study. And then what you'll see in the yellow book at the very bottom of the page is an H1, and then at the top of the next page is an H0, not an H2. So change that on your checklist. The H1 is your experimental hypothesis. So the independent and dependent variable are very clear, and they're operationalized in the statement. And they tell whether the hypothesis is a one-tailed or two-tailed, and I'll go over this in just a second. And then F, the last thing, is the null hypothesis. You're going to reword the experimental hypothesis to say no significant difference or change, or put it in a way that's opposite of your research. You are basically proving with this experiment that you're trying to prove the null hypothesis, that it won't make a difference. And we want to have that sort of mindset, because if we go into an experiment trying to prove our hypothesis, then we're going to look for data, and we're going to look for things, and we may have some kind of experimental bias that's going to try to create that situation, and that is going to be a problem with our data. So if you go into it thinking, no, this is not going to happen, I'm not going to prove my hypothesis, then that's a better way of sort of looking at it, and that's what true experiments are. If your data comes out and it does not follow and does not prove the hypothesis, that is totally okay. It's okay for your experiment to, quote, fail. That's part of research, and you're just going to, the most important thing is you're going to, label that correctly and honestly, and then the evaluation, you're going to tell and try to come up with the reasons why it actually failed and was not proven by the model, okay? So in writing the aim, as again, this is sort of towards the end of the intro. This is, you're writing your aim. It's more of a construct. So if you look at the bottom of the page, it comes with 3 elements: independent variable, dependent, and then the cause and effect. So an example is on Loftus and Palmer, to investigate the effect of post-event information on memory of the event in an eyewitness situation. So it's very construct. It's not operationalized. We haven't defined what post-event information is and memory is going to be. We're going to do that next in the research hypothesis. Okay, so that's more of a construct versus an operationalized one. The operationalized or research hypothesis is going to define what those constructs are that we've talked about before. So participants who are asked as questions with a verb of a higher emotional intensity will report higher speed estimates than participants who are asked a question with a verb of lower emotional intensity. Okay, it uses the operationalized variables. It's easy to tell that it's a group of participants that will be allocated to different conditions, and the hypothesis is directional. As the verb gets higher, so does the speed. They do get higher. So that's actually called a one-tail. And I'll go over that again when we get to the inferential statistics, but that's a one-tail. So that means the direction of the hypothesis is going in the same direction. Like the numbers will always increase or they'll always decrease. On a two-tailed, you have a possibility for them to go up or down. In the null hypothesis, which is the last thing that you write in the intro, it's the opposite of the operationalized research hypothesis. And again, that's based on our principles of falsification. So an example that doesn't use no significant difference, but you could do it as it says in the yellow book, is speed estimates reported by participants who are asked a question with a verb of higher emotional intensity will not be different from speed estimates of those with a lower intensity. So you can just put not, or at the very beginning, put it's no significant difference, and then restate the research hypothesis. It doesn't matter how you do that. It's just that you're doing the opposite of your operationalized research hypothesis. So make sure it's not a construct hypothesis. It's a operationalized, and it's the opposite of what you were thinking. So that's the end of the intro. If that's all you need, you can pause the video or you can listen to the exploration. Okay, the exploration is the second part that's based on your word count. And this is where you're going to really just talk about your experiment. The research design, the sample choices, choice of experiments, and there's all kinds of subheaders that you're going to use for that. So in the check sheet, you'll see all this. You want to be specific to your experiment, not general, and you're going to use a subtitle. In the yellow book, you will see that. It says research design, and it has a colon, and it's highlighted, and it's bolded, and then you're going to put what kind of research design you have. Remember, research design is not experiment. It is not experiment. A research design is either one of 3 things: independent measures, repeated measures, or matched pairs. That's what you're writing here. Pick one of those. Refer to your group folder on what you guys decided was the research design. Sample technique is the same thing. You want to refer to Unit 1 on certain types of sample technique, like convenience sampling, right? You don't want to use snowball sampling because that is a qualitative, not a quantitative. Quantitative is the only thing that we're doing right now in an experiment, is quantitative research. So you want to use the quantitative research sample vocabulary. You're also going to talk about your choice of your participants. Gender is a definite, how many males and females, the number of them, how you randomized, and so forth. The procedure, you're going to number those, and you can see that in the yellow book. You put procedure and you put number 1. What do we do first in the experiment? Not in the planning of the experiment, but the actual experiment itself. And then anytime you refer to, passing out, or, a debriefing statement, or administering the consent form, you want to put the appendix that it's in. So if the consent form is in Appendix 1, then that's how you would reference it, and you can see that in the yellow book. Next, you can also see, as you turn the page in the yellow book, the subtitles for variables, and then also subtitles, which are independent variable and dependent, and they're going to be operationalized. How are they defined? And you can see that there with the Lincoln example. And then controls, what are some possible confounding variables and how you would control for those. You're going to refer to internal validity vocabulary anytime you talk about a control, a limitation, a strength in the overall IA. You want to use the internal validity for experiments like maturation or demand characteristics, things like that we talked about in Unit 1. Do not use the qualitative limitations and strengths, use just the quantitative. And then materials, you're also going to have that list of materials that are specific to your experiment that are unique. Don't put down pens and pencils. Put down, word lists and such, and you're going to use the appendices as well and reference those in the appendices. And then as you go into the next page of the Yellow Book, you'll see the ethical considerations that you address specifically to your experiment, and then use the vocabulary in Unit 1 as well. So that's the end of the exploration. If that's all you need help with, you can pause it or you can fast forward and listen to the next section. The next section is talking about the analysis. This is probably one of the hardest things to do besides the evaluation, because you have to think about in the evaluation like some good answers. The analysis might be hard for some of you, might be very easy for some of you. It's just trying to figure out what you're actually going to use. The textbook itself, if you go to the textbook, the back of your textbook has the internal assessment. It's like an orange tab in the back of the book, and it has all kinds of things about the analysis and about descriptive versus inferential statistics. So in the mark bands for this, it says descriptive and inferential statistics are appropriately and accurately applied. So I'm going to talk about descriptive ones you need and also inferential. The graph is correctly presented and addresses the hypothesis. You need at least a graph. You can put a table in, which you're going to see, but the graph is essential. And the statistical findings are interpreted with regard to data and linked to the hypothesis. So on a graph, if you have two things on the x and the y axis that have nothing to do with the hypothesis, then you're not going to get points for that. So let's talk about descriptive statistics. If you look in your Yellow Book, you will see the analysis heading, and then you'll also see a subheading of a descriptive statistics, and it's listed there in your check sheet to put down a subtitle called descriptive statistics. This is where you're going to look at measures of central tendency and dispersion like standard deviation. You're going to determine the level of measurement for the dependent variable, okay? And you're going to want to look at the normality of the distribution. And a histogram, does it have a bell curve? Or is all of your data on all kinds of things? You have all kinds of extreme pieces of data. That's going to determine what kind of measure of central tendency that you use. You also want to determine what's the level of measurement that you have for the dependent variable, meaning what kind of data does your dependent variable have? And that's going to decide on what you use for the inferential statistics, okay? There's 4 different kinds of data that you can possibly have: nominal, ordinal, interval, and ratio. And so you can look up either on Google to see on the internet to see like what yours would actually be if you're not clear after I explain this. But you need to be able to try to figure out what it is. For nominal, it's just categories, yes or no kinds of questions. Your married status, are you married or not, divorced, those are categories. And the number of people that actually answer that is a number, but the actual data itself was based on a category that they had to answer. Ordinal data is ranking from highest to lowest. And so for this, it would be like a rating from 1 to 5 on something, or letter grades are ranked, and so forth. The type of data of ordinal would be that. Interval data are things, differences between measurements like standardized exam scores show differences. They're not ranked, they just show highest to lowest, but the intervals assumed to be equal and 0 is not absent. So degrees in a thermometer, like 0 is still there, and so forth. And then ratio is like number of words recalled, okay? Height, age, weekly food spending. It doesn't have a highest to low, it's just a number that's sort of there. And 0 is meaningful also in that scenario. All right, so what are the measures of central tendency? You all have seen these before: mean, median, and mode. So based on the type of data you have, when the level of measurement is interval or ratio, you're going to use the mean, because you're probably going to have something where there is like a normal curve, a normal histogram there, as you see on the right. The level of measurement is, if it's ordinal, the mean can't be used, so we're going to use median. And then the level of measurement for nominal, we usually use mode. Most of you are going to be using mean or median, depending. But just keep that in mind. If you have nominal, it's possible you have nominal, you're going to use mode. The measures of dispersion makes sense of the data, and the measurements of central tendency may not be enough, because some data is more spread out than around the center than others. So we have two types of that, and it's actually three. There's range in there too, but standard deviation is used with mean, and then semi-quartile range or range, semi-interquartile range is usually used. When we look at standard deviation, it takes into account all the individual values. So if you have outliers, like really extreme data, you have some in the middle and you've got some extreme data on either side, which I know I've heard some of you say. If you take out those, it really changes the mean. So we have to really think about, like, when we're using the mean and we have outliers, we may want to use median. When you use median, you're going to use interquartile. If you don't have a lot of outliers, and you can do this by actually creating a histogram of yourself and seeing if there's actually a bell curve first. I mean, just plotting the data points and so forth on a bar graph histogram. If you feel like you have got big outliers, if you take those outliers out, it really changes the mean. So you really want to use the median. But if you don't have a lot of outliers, then using mean and standard deviation is going to be appropriate for you. So you're going to calculate standard deviation. You can use any kind of Google YouTube video to remind yourself of how to do this. It will go through all of those, and that's the formula on the side there. And this can't be used with nominal or ordinal because of it can't be used with nominal or ordinal data sets with severe violations. It can be used, and in fact, most of the time, standard deviation and mean are used. But if you have a big distribution, you have a lot of, you have a really small sample, and then you have big outliers, that might be us, because we have smaller samples, right? And so we have to evaluate for those big outliers. If that's the case, you can't use, even with nominal and ordinal, you can't use standard deviation. And you wouldn't use mean either. So you have to use the ones that are more appropriate for outliers, so it's a better representation. So if you're not sure if you do have a normal distribution, just go ahead and you can put your raw data into an Excel spreadsheet or a spreadsheet on Google Sheets, and then it creates a raw table for you, and then you can see, okay, I know I have outliers, but is it actually a normal curve? If it's a normal curve, then you can go ahead and use mean and standard deviation. That's okay. If it's not, then we're going to use, we probably are going to be using median and semi-quartile range. So you're going to calculate the median, and then you're actually going to be calculating the semi-interquartile range, which I know some of you have done. There is a video on how to do the plotting of this, and how to take your actual data and then find that range, and then how to create a box plot for that in order to do that. So one of the things you're going to be doing, as you see in your yellow book, is what do you do with your measures of central tendency? There is a table in there, but on the rubric it says graph. So you don't have to put the table in. You can if you'd like, but then the graph on the next page that you see of the descriptive, it has a bar graph for the means of two different types of conditions in this one, and then it has the little line that you see on the graph that I have on the video here that shows the standard deviation. So the bar graph on here are all the means of different data sets, and then the little lines show the dispersion. So the error bar denotes the standard deviation that you calculated using that formula. On an interquartile range, you would have median bars, but then you would have a interquartile box plot that would be put on your graph. There's all kinds of programs online that you can plug this stuff in, and it will create a graph for you, and so forth. You can use your Microsoft Excel or to create a bar chart with arrow bars on it, okay? So you don't have to draw those out on your own. They can be created pretty easily. So make sure that the chart is clear and it clearly links to the hypothesis. So in this example on the right, age group is one of my independent variable, and then my framing score is probably my dependent variable, and that's very clear that those are the things that are in my research hypothesis, and then the statistics are showing those two types of variables in my chart as well. Okay. Avoid labels that are vague. Make sure it's directly the ones that are in your hypothesis to link those two sections. Use the units of measure for the dependent variable in this, and then be clear. And make sure, I put it in your check sheet as a note, do not make a bar graph that exaggerates and makes it look like yours is very, has a significant difference. You want to use the lowest possible value on your y-axis, and then if 0, that might be that, or it might not be. It might be 5, and then just do correct intervals all the way to the largest possible value, and put it in there. If it's a large value of 100, then you're not going to go 1, 2, 3, 4. You might do intervals of 10, and that way the bar graph is not exaggerated. It's okay if it shows no difference or inverted, or it's just a little bit of a difference. It's more honest that way. So the main body of the analysis section, you'll have an explanation of why the methods were used for central tendency. So you'll see in the yellow book, it has like a little description of the table. It shows the table and some numeric data in the hypothesis. And again, you don't need to put the table, but if you'd like, you can. It's the graph 1 that you see that's the most important, that it shows the central tendency and the standard deviation. And so you're going to put an explanation of why you chose the mean, median, or mode, and then why you chose your dispersion, like standard deviation. You can show that in the graph, and again, don't make the graph exaggerated. In the appendices, that is where you're going to actually put your calculations. If you turn to appendices 8, I think it is, 7 and 8, in the yellow book, 7 and 8 in the yellow book, you will see the following. You'll see the raw data that you should have for your group. And then you'll see the calculations for the descriptive statistics. And then if you turn the page again, you'll see the screenshot of the calculations for the inferential test. You have to show your work. You can't just come up with numbers, and that's because people could easily cheat and say this is my U score or whatever it is. You have to show your work. So it's appropriate to use any kind of calculator, even on your phone, to come up with calculations for the mean, median, mode, and then show those and take a screenshot of them and how you did that. You could, calculate it on a piece of paper and take a picture of that. It doesn't matter how it's calculated. And as you see in the appendices, they do add a link that talks about, that shows that they use this calculator link online. You can't just put the calculator link in the appendices. You have to put the calculator link that you used online, the tool that you used to calculate these things, and then you have to actually show your work of where the numbers came from. So remember, that does not go in the body of your IA. It goes in the appendices, and you have to have it, else it's invalid. The inferential statistics is the second part. If you turn your page back to the main body of in your yellow book, there was descriptive statistics, but now we're going to look at the little paragraph that says inferential. All of in the appendices, that whole section in the inferential shows you how to calculate a Manny-Whitney test. Not all of you will be using that test, and in the textbook it talks about different sections about what kinds of tests should be used. That is all the calculations for this little paragraph that's in the main body. But inferential statistics are going to be based on your experimental design, if you had independent measures or repeated measures and so forth, and the level of measurement. So what kind of data that you have, okay? And it's going to tell us whether or not our numbers were significant. If it was significant, then you're going to be able to say that you could probably prove your research hypothesis and reject the null hypothesis. In your book, you will see this little chart, and it's really, really helpful as to what kind of data you have and then what kind of experimental design you have. If you have parametric, is if the mean's more accurate representative to the distribution. So if you have a really normal bell curve, you have parametric. If you have non-parametric, then you're using the median instead, and you probably are using interquartile, and you have like a skewed histogram. All right. Again, one-tailed, as you're going to see in inferential statistics, is the hypothesis direction goes in one way, increase, and the hypothesis direction goes in both ways, either increase or decrease, and that will depend on what kind of critical value you're going to have from a table. Okay. Should you choose parametric or non-parametric tests? Again, mean and median are going to make those decisions on how normal your bell curve is. There are 4 different tests that you can basically test, or there's a little bit more than that. There's the unrelated and related t-tests, Mann, Whitney, Wilcox, and then chi-square, and also the McNaram one as well. Most of you will be using the Mann-U test and the Wilcox test because both of those do ordinal, interval, and ratio. If you look on that chart in your book, most of them do that. Nominal data, you're going to be using chi-square, but some of you may use as well. If you have a yes, no, or category type data, you're going to be using that, and that will depend if you have independent measures or repeated measures, as you see there. The t-test in the book, it will go over how to actually use this. This is for interval and ratio measures and for independent measures, but you can also use the Mann-U test as well, and I would suggest maybe using that one since you know, that one tends to be one that's more highly used. You're getting a U-score versus a t-score. But if this one, this t-score, you can't have a sample no fewer than 15. So if you have a sample of 20, which most of you don't, then you can use this one if it's easier for you. However, if it's not, if you have less than 15, you're going to use the Mann-Whitney U test. Okay, and that's the one that's listed and shown in your, or the calculations are shown in your yellow book. This will tell you, you can look up things online to how to do a U-score, and I have some videos on Canvas for that. And again, this is for independent measures. You can also choose the t-test, and that is for a repeated measure situation for interval and ratio. You can also use the Wilcox as well, and this again, no less than 15. Most of you are not going to be using unrelated t-tests and t-tests just based on the size of your sample. So most of you will be using the Mann-U Whitney U test for the independent measures because of the size of your samples. Unless you have nominal data, then you're going to use the chi-square. And if you have a small sample for repeated measures, you're probably not going to be using the related t-test. You're probably going to be using the Wilcox rank test for repeated measures. Unless you have nominal data, then you're going to be doing the McNaram test instead. Hopefully that's clear. All of these things, the Wilcox rank test, it tells you in your book, and you need to be able to rank order in ordinal data, and it's again a repeated measure kind of situation. It will teach you how to do that, and you can also use videos as well. For ordinal data, the most common is chi-square. So again, for independent measures, for most of the data, Mann-Whitney U. For repeated measures, Wilcox. And for nominal, most of you will use chi-square if it's the independent measures, okay? And chi-square has a formula to get a number for that. And there's also videos I'm going to have for that. And then for repeated measures, you use this formula for chi-square, but you just looked at different information. So at the top, you can see the chi-square test was used here. Somebody experiencing joint pain is associated with running more than 25 kilometers a week. But this comparison is just on the yes. It boils down the comparison of the two purple, the runners and the non-runners. In the McNaram, you'll see that we compare the same thing, the same data, but we're going to use different columns to do that. Okay. With all of those tests, you're going to see a critical value table, and in your textbook it shows you one of those, and I think it's on page 503, I believe. It shows you a critical value. So once you find, let's say, a U-score of like 21, then it will tell you on the directions of how to use the test to find a P-score Then you're going to be looking at the p-score and where on the p-score, what your u-value, which p-score goes along with it based on if you're a one-tail or a two-tail hypothesis. And so again, you can refer to your book about how to get that critical value off of the chart, the critical value chart. Those critical value charts can be found online. And then you look to see what that U value, for instance, or W value for Wilcox is going to show you. And you're going to find the P values, which is going to show you your significance. If you go to your checklist under analysis, you'll see under the little notes I have what exactly the paragraph is going to explain. And it's going to explain the results of the, why you picked that inferential test based on your type of data, and also your sample size possibly, and your research design. You're going to give those scores for that test, and then you're going to put down what kind of p-value it is, and you can follow along in the yellow book to see what that format looks like. The p-score is going to tell you, is it 0.05, is it 0.01? What is the significance of your data? If it's 0.1, then it's not significant, because that's 10% of the time the null hypothesis is true. And we don't want the null hypothesis to be true no more than 5% of the time. So that means that that significant value, like we've talked about in Unit 1, that 95% of the time your research hypothesis is going to be true based on the data that you've pulled if you did the test again or you did the experiment again. All right, so that's important stuff to say whether or not you can accept. If in the inferential statistics you find it's more than 5%, then you have to accept the null hypothesis, and that means your research hypothesis was not proven. You have to reject it. If it's 5% or less, then you can reject the null hypothesis and talk about how it is and talk about how it is the research hypothesis that was proven. Okay. Useful resources are going to be looking up the critical value tables and so forth. You can look at those. There's some at the end of your chapter on the IA in the textbook. You can look up the critical value tables for the t-test, the Man-U test, and the Wilcox in order to find those p-scores and so forth. This is really the part where you really have to do a lot of independent work and make sure that you're really just sitting down and thinking about it. If you follow the checklist and then you just follow my directions in that chart in your book and try to figure out, okay, what's the best test for me to use, and you can validate that, then you'll be fine, because you're going to be using appropriate tools to find the significance. So, like I said, in the inferential, you want to be clear about how those statistics are clearly shown on the hypothesis and whether or not you're accepting your null hypothesis or not. You're going to use the critical tables, and then you're going to at the end of that paragraph you're going to be rejecting or accepting the null hypothesis and then tying it back to the research hypothesis. Okay, so if you're done with this and you are ready to just do the analysis, you can do the analysis, or you can listen to the evaluation and what the evaluation is. In the evaluation, that's the last word count section. You're going to write about the theory or model. You're going to be talking about strengths and limitations of design, sample, and procedures, and you're also going to have modifications. That's the simple part of it. It's a pretty long section because you have to actually provide some kind of detailed information, but let's go through what it's going to look like on your check sheet. So first of all, you're going to discuss the results of the experiment. Was it successful to the aims of your study? And you can reference the original study unless you're going over on word count. Then don't worry about putting in the original study. And if you proved something as well like the original study, don't worry about that. You can just talk about your own study and if the significance was shown to prove it or not. Most important is going to be linking the results back to your theory. Link the results back to your theory. It's the most important. Can the results be explained by the theory or model? And reference it in that manner. Can the results be explained by the theory or model? And you're going to link that. You're going to talk about what the theory or model says about your results. The next and most important thing is talking about strengths, limitations, and modifications. For each of the three, you cannot leave out one of these: design, sample, and procedure. And you're going to use those internal validity and external validity, construct validity type things to discuss that. All right, you must have at least one strength, one limitation, and one modification for each design, sample, and procedure. Think about the measures, the tools, the controls, creating that causal relationship. How did your experiment do those kinds of things? And then you're going to conclude on the null hypothesis and link it back to the model, like was the null hypothesis proven and so forth. In the planning of the evaluation, besides the theory or model, this might be a good tool for you to use. You're going to talk about if the experiment was successful, how did the model explain the results, if not, give the alternatives. And then you may want to come up with a chart of design, sample, and procedure, and then strength, limitation, modification for each, and then turn those into sentences. And if you do that, you can do a paragraph for the design, paragraph for sample, paragraph for procedure, and that way you would have a paragraph for each, and you have some good information there. A tip there too, if in a design the limitation is like your strongest point, put it first, and then maybe put the strength in the modification. Depending on the strength, put the strongest points first and the weakest last. So it's like you start strong on design, but then you kind of hide up. You're like, oh, I don't really have a good strength. And I can't really tell you those things. You have to evaluate it yourself. And so I can tell you to work on the strengths and modifications, limitations, but I can't tell you exactly which one because that would be me telling you the answers. So you have to really be thinking about that. But the best thing is if you have a really strong point and it's the modification, put that first. And then if your strength is the next and then your limitation is the least, then put the weakest one last so it kind of hides what you're sort of having trouble with. Okay, that evaluation is a little bit long because you have to really evaluate what you did, but it's very simple in what it needs to do. Again, all the parts, if you follow the checklist, are really not that difficult. Okay, the last part of the checklist is not on the word count, and that's the works cited. It has to be in APA format and alphabetical order by citation. Again, those citations are mainly coming from your introduction and then also the original study, the citation for the original study. The appendices, again, look at your yellow book to look at the things that are in it. They're going to come from your group folder: raw data, calculations, consent form, instructions, debriefing, supplementary materials you used for a specific to your experiment. That all has to go in. Remember those calculations have to be in there and they have to show your work as well as the calculator that you may have used online. So good luck with everyone. Use your check sheet. If you use your check sheet, you will achieve all the things that are on the IB rubric. Go step by step, look at the yellow book, look at your textbook for the format of it to see kind of how it was sort of written. It's not that big a deal. Just get started on it and really use that check sheet to make sure you put those things in, and look up things that you don't understand. Send me emails if you need some direction on something, and I know you're going to do a wonderful job. Do as best you can on this rough draft. All right, guys, talk to you later.